Okay, so now I'm recording right now. Okay, so this is the equation for progressive wave. Okay, as we learned, our progressive wave is actually okay. We are learning about mechanical wave, right? Mechanical wave. Mechanical wave is it needs medium to transfer energy. When talk about transfer of energy through medium particles, so that means it involves many oscillation of particles. As you can see, like this string, it involves the oscillation of all the string particles. If water, oscillation of all the water particles. Just like this one, you see. In order to transfer the energy from left to right, it involves oscillation of all the medium particles. You see that? All the medium particles oscillate in order to transfer the energy. Okay, so previously in simple harmonic motion, we just talked about oscillation of just one particle. Okay, just one particle. Now we have many particles, right? We have many particles, not just one. Okay, so this chapter, if you look at here, 7.1 to 7.3 is about simple harmonic motion. 7.4 and 7.5 is about mechanical wave. Okay, so this is for just oscillation of one particle only. Okay, this one is oscillation of many particles. Okay, so that's why the formula also changes. The formula last time is as simple as y equal to a sine omega t. Now it has become what? It has become a sine omega t plus minus kx. Okay. So actually, I just want to write down all the things again here. So in 7.1 to 7.3, oh, this is too big. This is about right. Okay, so in 7.1 to 7.3, we are talking about simple harmonic motion. So later now, 7.4 to 7.5, we are focusing on mechanical wave. Mechanical wave. So this one, oscillation, oscillation of only one particle. This one is oscillation of many particles. Why is it like that? Because we are talking about using the medium, medium particles to transfer the energy, for mechanical wave, all the medium particles. Okay, so one particle versus many particles. So last time we have all these equation. For example, you have y versus time equation, we have a velocity time equation, we have velocity versus displacement equation, we have acceleration time equation, we have acceleration versus displacement equation, we have the potential energy versus displacement, the kinetic energy versus displacement, we have a total energy versus displacement equation. So if I want to write everything down, okay, y equal to a sine omega t, and then we have v equal to a omega cos omega t, and then we have v equal to plus minus omega, this one is a square minus y square, and then we have acceleration time is a equal to negative a omega square sine omega t, and then acceleration displacement is negative omega square y, and then so on, all the kinetic energy. Do you know that it's actually all this formula will be used back in 7.4 and 7.5? You know that it will be used back in here. Dia diguna balik di sini. Kamu tahu tak? Kelas, kamu tahu tak dia guna balik di sini? So soft. Your sound is so soft. Can you say louder? Other people, are you listening, class?
Yes, sir.
Yes, sir.
Okay, speak louder, yeah. I hardly hear your sound. So we use back all the formula again from simple harmonic motion. Use back again because it's talking about oscillation. It's still about oscillation, but now not just one particle. This one particle we use omega t. This time we are talking about many particles. Many particles. So oscillation of many particles. We still talk about oscillation. But now we do a little bit of modification. We put plus minus kx into the equation because we need the x to show which particle. Yeah, what is x? What is x? X is like, for example, like okay, like you I want to talk about this particle here. So this particle is, x1 distant away from the source of disturbance. I want to talk about this particle. This particle is, x2 distant away. So x is to show, what is x? X is to show the distance of particle from the origin. Okay, that's the purpose of x here. Okay, so this equation we still use back, but we do a little bit of modification. So how we do it? So we put plus minus kx into it. Here we have plus minus kx, and then here we have plus minus kx. Understand, class?
Yes.
But the formula is the same. Yeah. So all the other formula is still used back because we still talk about oscillation. Still talk about the same thing. But now with many particles. So we need a positive negative kx to show which particle. Okay? The format of the equation is still the same. Yeah? And then this v versus y equation, positive negative omega a square root a square minus y square is still the same. Okay? And when we want to talk about, want to talk about maximum, maximum value, put this a little bit further away. Okay, when we talk about maximum value, for example, y maximum is amplitude, v maximum is a omega, a maximum is what? What is A maximum? A omega square. So same thing also. For mechanical wave. You have maximum displacement amplitude. You have maximum velocity also. We have maximum acceleration also. And then another thing is where is the maximum velocity happen? It happened at what? Where? It happened velocity maximum at y equal to 0 at equilibrium, kan? But A maximum at y at amplitude. Yeah? A maximum at amplitude. So all this is the same thing again, yeah? Okay, now one thing I want you to pay attention. Yeah, so we also can find the formula for energy, potential energy, kinetic energy, total energy, or yeah. Now, one thing I want you to pay attention is the following part. This one. However, for velocity formula, we have two formula. Okay. Last time we just talked about velocity. This is velocity of oscillation of particles, right? Velocity of oscillation of particles. This time, yeah, this is what we learned in the past. Velocity of the particle. See that? A omega cos omega t plus minus kx, omega square root a square minus y square, which is these two formula kan? Where is it? Is it these two? Betul tak? So is it the same? This formula and this formula lah, betul tak? There's a particle vibrational velocity. That means velocity of you see, velocity of this is the particle vibrational velocity. Understand? You see lah, string particle, Vy. There's particle vibrational velocity. Can you read? Particle vibrational velocity is velocity of particle in which they oscillate about equilibrium position in simple harmonic motion that generate wave. So it's talking about particle vibrational velocity. But there's another velocity we call wave propagation velocity, which is this green one. V equal to f lambda. You see the whole wave. You see the whole wave actually is moving to the right. That is the hey, no other color. Oh god. See, that is the wave propagation velocity, which is v equal to f lambda. Particle vibration velocity is yang panjang-panjang punya, very long one equation. Okay, particle vibration velocity. The difference between these two velocity, okay, wave propagation velocity. Wave propagation velocity is velocity of the wave lah. Velocity of the wave move forward. Yeah, velocity of the wave move forward. Is v equal to f lambda or lambda over period. Yeah, because why? Because frequency is 1 over period. Yeah, frequency is 1 over period. So substitute inside, so we get lambda over period lah. So can be like that. So what's the difference between these two velocity? Particle velocity and wave velocity. Yeah, one is particle velocity, another one is wave velocity. What's the difference? The difference is this particle velocity changes with time, varies with time. Wave velocity is constant. Wave velocity is constant, but particle velocity is varies with time. It's always changing. Always changing. Betul tak? Is it changing? Is it changing?
Yes, sir.
Yes, because last time we learned kan, kan dia ada velocity maximum, velocity minimum. Bila dia maximum? Bila dia maximum? Bila kamu tengok, bila partikel, contohlah, bila di sini, ini bila di sini, velocity, see the arrow here, velocity maximum at equilibrium, the equilibrium, velocity maximum, which is a omega, betul tak? Kalau di partikel, kalau sudah sampai di amplitude, velocity zero, velocity minimum. So velocity zero at amplitude, but velocity maximum at equilibrium. So that's why particle vibration velocity varies with time. It is the same thing like this particle vibration velocity. It's the same thing like oscillation of simple pendulum. See this one? Velocity maximum at equilibrium, but at amplitude velocity zero. So varies with time. Okay. This slide have I taught you before? Not yet, right? Previous class I haven't taught you, right?
Okay.
Haven't gone? Okay, so it's changing with time, yeah, varies with time, but wave velocity is constant. Okay, we have two formula to find particle vibration velocity. One is using this one, omega t plus minus kx. Another one is you give displacement, you can find velocity. So got two equation can find the same thing lah. Can find the particle vibration velocity. Dia tulis sebagai Vy. Ini tulis sebagai V saja. Alright? Good. Now this one. We have so wait. So we have all the okay. Good. Let me so this one, Okay, now next this one. Displacement graphs of the wave. What does it mean? Why we have two graphs here? Wait, what is this? Why we have two graphs here? One is displacement distance, one is displacement time graph. What's the difference? See that? Okay, look at displacement distance first. Displacement distance, it shows the displacement of all particles in the wave at any particular time. It shows all particles. Or you can, in other words, it shows the whole wave. It shows the whole wave. My writing shows the whole wave profile. Shows the whole wave profile at any particular time, at certain time. Yeah, it can give you. This one normally he give you the time. Yeah, he give you the time. Let's say, at x, at time at time 1 equal to 6 seconds, or at time equal to 10 seconds, macam tu. Okay, kalau y versus x dia akan bagi masa. Kalau y versus time dia akan bagi distance, ya. At let's say at x equal to 2 meter or x equal to 5 meter and so on. Okay. Nanti saya akan explain tentang ini. Kenapa ini bagi distance, ini bagi masa. Okay. At any particular time. Yeah. Particular time means that, let's say time 1 equal to 6 seconds or 10 seconds. Okay. What does it mean by this statement? This graph shows the displacement of all particles. This is the displacement versus distance graph. Displacement. So kadang-kadang ya kena ingat unit dia juga. Unit dia penting juga. Kalau displacement graph, displacement dia bagi cm. Kalau distance dia bagi contoh lah ya, ini x kan, ini x. Dia bagi ini dalam meter. Hati-hati juga kelas. Kalau displacement ini bagi apa dalam cm, that means what? That means what? That means the amplitude here. This one is the amplitude. You understand? This is the amplitude. Amplitude dia dalam cm juga. Understand or not?
Yes.
If distance is meter, that means lambda also in meter. So this one refer to y, this one refer to x. Okay? The unit. So pay attention to the unit at the axis. And this one you can get the wavelength. Okay, so what does it mean by this graph? Yeah, many people still ask. Yeah, what does it mean by this graph? This graph shows the displacement of all particles at certain time. That means maybe what I can say is maybe I better wait. Let me show here. Okay. So maybe this graph is the graph at I put the time there. Time at maybe the time at 6 seconds. This is the graph when time equal to 6 seconds. And you can see all the particles happen at 6 seconds. All the particles, the whole wave. You can see the whole wave at 6 seconds. Static at 6 seconds. Understand, class? This is the graph to shows the whole wave or ataupun all particles at certain time. So maybe at time equal to 6 seconds. And let's say the wave is moving to the right. Let's say the wave is moving to the wave is moving to the right. Iaitu negative kx. Ya, negative kx ialah direction kan, negative kx. You understand why it's negative kx? The direction, the direction. Negative means direction lah, to the right. Okay, let's say the wave is moving to the right, and this wave is the whole wave at 6 seconds. The whole wave is at 6 seconds. It is at this position. Okay, all the particles at this position, they all have different displacement. You can see. So let's say after 4 seconds, so at time equal to 10 seconds, yeah, after 4 seconds is time 10 seconds. The wave has moved to the right. The wave has moved to the right. So let me draw it. The wave has moved to the right, so maybe it will move to over here. Move to here. Move to here. Wait a second. Lukisan saya tak bagus lah. So after 4 seconds, the wave has moved there. So this is at time equal to time 2 equal to 10 seconds. So the wave has moved to the right. Understand, class? So that means this particle, the first particle has moved down. The second particle has moved to here. Third particle moved to here. Fourth particle moved to here, and so on. So this is the wave at 10 seconds. The green one. Okay, so what I'm trying to say here is this graph is to show the whole wave at certain time, at any particular time, at certain time. So will be given time. This time will be given at any given time. You can see the whole wave. That's why, since the graph you can see the whole wave, so you can know the wavelength. Because you can see the whole wave. You can see the wavelength. How to find the wavelength? Wavelength is, you can take what position as to find the wavelength. You can take, let's say, these two position. You see, these two position. This is considered as one wavelength already, kan? Correct or not? Or you see, from here to here. This is also another. Yeah, from here to here also another wavelength. Or you can say, from crest to crest, from here up to here, also another wavelength. Betul tak, kelas?
Yes.
Or kalau from here to here, this is considered as half wavelength. Okay? Because you can see the whole wave profile. Wave padam sudah ni. Okay, then what about this one? Y versus time graph. Displacement versus time graph. What does it mean? The graph shows displacement of any one particle. This one only, how many particle? One particle. One particle at certain distance. Dulu is certain time. This one at certain distance. At certain distance. At particular distance. At certain distance. Or given distance, at any given distance. Given x lah, dulu given t kan, sekarang given x. Maybe x equal to 2 meter or x equal to 5 meter. Kamu faham tak ini? Ini oscillation of how many particle? One particle. That means kita rujuk kepada y versus x graph dulu. Y versus x graph. X equal to 2 meter itu di mana? X equal to 2 meter itu mungkin di inilah, ini. Mungkin di ini. Mungkin partikel ataupun ambil ini. Ambil ini. Kelas ambil ini. X equal to 2 meter itu mungkin di sini. Saya nak tulis di mana X equal to di inilah. Ini. X equal to 2 meter. Ini X1 lah. Kelas? So, X1 means particle ini. Kelas, particle ini. So, particle ini. So, maksudnya apa? Graph ini apa? Graph ini ialah, what is this graph? This graph is to show the oscillation of what? Of X1 particle. It shows the oscillation of X1 particle over time. Only the X1 particle. Only the X1 particle. How it oscillate up and down, up and down, up and down, up and down, up and down over time. Graph ini hanya fokus kepada partikel X1 sahaja. Partikel yang lain tak tengok langsung. Faham tak?
Faham, sir.
Faham, sir.
So that means dulu dia bagi ini di graph ini bagi masa kan? Maybe this one is the graph at certain time, at time equal to at time 6 seconds. So it shows the graph, the whole wave at this time. This one, it shows the oscillation of one particle at certain distance at x1 equal to 2 meter. The particle at it shows the oscillation of particle at x1 equal to 2 meter. So this is the story of inilah cerita untuk partikel di x1 sahaja. Dia bukan cerita untuk partikel-partikel yang lain. Dia tak hirau pun partikel-partikel yang lain. Faham tak? This is the story or the history of this is the cerita untuk partikel x1 sahaja. Macam mana dia oscillate over time. Okay? Saya boleh juga concern partikel lain. Saya tak nak tengok x1. Saya tengok x2 lah. Contoh x2. So, partikel at x2. So, x2, kalau saya nak lukis graph. Saya nak lukis graph untuk partikel x2. Iaitu di 5 meter. 5 meter tu di mana? 2 meter, 4 meter, 5 meter. 5 meter mungkin di sebelah sini. Partikel yang ini. Partikel yang ini. Kan? Ini jadi x2 sudah. Ini jadi x2 sudah 5 meter. Kalau you nak tunjuk graph untuk x2 sahaja pun boleh. So dia hanya cerita pasal oscillation of this particle ni lah at x2 over time. Macam mana dia pergi up and down, 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 over time. So itulah dia. Yeah. So it shows the oscillation of the particle at maybe this position over time. So that's why it just focus on one particle at certain distance. Okay. So since it only focus on one particle, we can see how much time it used to complete one oscillation. See, like particle at x2 kan, x2. So how much time it used to complete one oscillation? How much time? From here it go up, go down, back to original position. So how much time it used to complete one oscillation? How much time? So maybe you know, maybe 0, 2, 4, 6, 8. So how much time it used? At 2 second, at 2 second particle x 5 meter ini x2 ini dia berada di equilibrium. Lepas tu lepas 2 saat dia kembali ke origin. So at 4 second it back to origin. At 2 second it is origin. At 4 second it also back to origin. So how much time it used to complete one oscillation?
2 seconds.
2 seconds. Betul tak? Okay. So dia boleh cari period untuk graf ini. So hati-hati, kadang-kadang time dia bukan bagi dalam second, kadang-kadang boleh dalam millisecond. Kalau dalam millisecond, period dia pun dalam millisecond, no? Faham? So ini unit kena ikut. Unit ini kena ikut. This unit must follow the axis. So if time is in milliseconds, so the period will be in millisecond. Be millisecond. If you must look at the time axis. This one also can show the amplitude. Let's say our amplitude is in centimeter. So our amplitude also in centimeter. It also shows amplitude. This one also give you the amplitude. The amplitude needs to follow the is in centimeter. Must follow the y-axis. Class, faham ke? So y versus x, it shows the whole wave. It shows many particles at certain time. Okay, it shows the whole wave. Since it shows the whole wave, you can find the wavelength. Yeah, the wavelength. Yeah, the x-axis give you the wavelength. This one shows the oscillation of just one particle at certain distance. Yeah, oscillation of one particle at certain distance. So you can find how much time. It used to complete one oscillation. When is it at the equilibrium, and when is it returned to equilibrium? Or you also can, not necessarily must go to equilibrium. You can also, from trough to trough, back to the original position. Yeah, if you measure from the trough, then you back to the trough at what time? Then you can minus out. You can find the period also, isn't it? From crest to crest, also one period. You start to measure the time from the crest, and then you return to the crest, also considered as one period. Understand, class? Boleh faham ke?
Faham, sir.
So y versus x graph give you lambda, y versus time graph give you period. Is it fair for you? Is it fair? Yeah. So satu bagi lambda, satu bagi period, dan bukan itu sahaja. You tahu tak betapa pentingnya benda ini? You tahu tak betapa pentingnya benda ini? Keep it. Okay? You tahu tak betapa pentingnya benda ini? Look at the equation. What do these two graph alone can help you to generate the equation for the graph, for the wave. You see, omega. You want to know omega, you need to know the period, isn't it? Kalau nak cari omega, kena tahu apa? Kena tahu apa? Sebut. Period. Kalau nak tahu wave number, kena tahu apa? You must know what? Wavelength. And then you need one more. So once you know lambda, you can find k, isn't it?
Yes.
Once you know period, you can find omega, isn't it?
Yes.
And you also must know the amplitude. If we know these three things, A, omega, and K, we can build equation for the progressive wave, isn't it? So you see, these two graphs can help us to build the equation. Why not? Because we can find lambda from here, you can find period from here, so we can find K from here, you can find omega from here, and we know the amplitude, and so we can build equation. So look at here. Yeah, so this one, class. So this one, this graph, you can help you to get the wavelength, and so we can find the K, because K is 2 pi over wavelength, so we can find K from this graph. And then this graph can help us to find period, and because we know period, we can find the omega, because the omega is 2 pi over period, or 2 pi frequency, isn't it? We can know frequency also. We can know period, we can know frequency. So we can know K and can know omega from these two graphs. And then both graphs also give us the amplitude, correct or not? You also give us the amplitude. So these two graphs end up, we can build equation for the whole wave. Sebab apa? Sebab kita boleh dapat semua nilai amplitude, omega dan K daripada dua graf ini. Faham ke kelas?
Ya.
Lagi satu. Selain daripada other than building equation, we can also, once we know the lambda, once we know the period, we can also find what? Wave propagation velocity. V equal to F lambda. Because V is lambda over period. See that? So these two graphs can also help us to find another thing, which is what? Which is V, use red color. V equal to F lambda. Because frequency we can get from, because frequency is 1 over period, right or not? Frequency is 1 over period, so we can get frequency. From, this graph. Can get both period and frequency from this graph. We can also get wavelength from Y versus S graph. We can get wavelength. So can we find the wave speed from these two graphs? Can we find the wave speed? Boleh ya. We can find the wave V equal to F lambda, wave speed. So itulah maksudnya. Okay. Now here there are two questions. Yeah. Which of the following wave is not a mechanical wave? Yeah. Which following wave is not a mechanical wave? Which one?
Light.
Light is not a mechanical wave because it's electromagnetic wave. Why is it not a mechanical wave? Why is it light not a mechanical wave?
No medium.
Ya, betul. No medium. Betul ya. Means you ada tengok video sebelum. Saya ada cerita pasal ini kan. Electromagnetic wave, no need medium. Light wave, no need medium. The light, we can feel the light from the sun. The sun travel through the space with no air particle, no medium. But we still feel the hotness, the hot of light, the heat of light. We still feel the heat of light. So the light reach our earth without any medium. But mechanical wave needs medium. Apa yang you nampak di sini? This is medium. You understand? What is this? It's medium. What is this? This is medium particles. You understand? Oscillation of many medium particles. Okay. So that's right. So light is not using oscillation of many particles. It's not using many particles oscillation. Is using interaction between electric wave and electric field and magnetic field. No particle there. There's no particle there. Yeah, there's no oscillation of many particles. No, is light wave is how the electric field and magnetic field interact with each other. How they interact with each other. So it's not about oscillation of many particle. Yeah. So it's not a mechanical wave, yeah. So we are focusing on mechanical wave, just the many particles, medium. So the water wave, sound wave, slinky. So light is not. Okay, answer is D. Now the distance between two successive crests on the wave is called what? The distance between two crests.
Wavelength.
Wavelength, yeah. Between two crests, between dua puncak, wavelength lah, betul tak? Distance between two crests is the wavelength, lambda. Between two trough also wavelength. Okay, so it's a wavelength. Okay, so that's all for 7.4. So the following are the tutorial questions, which I will upload now also, yeah, including this video. Yeah, I will upload. So please watch the tutorial video 8, 9, 10 from my YouTube, because next class I'm going to continue with question 11 straight away. I don't want to waste time. Okay, so please use your weekend. To watch my tutorial videos 8, 9, 10 and try to solve the questions. Yeah, because I already discussed. So use your weekend time to watch 8, 9, 10 from my YouTube. Next class, I straight away discuss question 11. Okay, save our time. Yeah, but use more of your time. Okay, so that's all for today's class. Any question? Any question, class?
All good. So far, no, sir.
Okay, good. So I hope that you understand. Okay, happy weekend. Okay, see you next class. Bye.
Bye,
Thank you,
sir.
sir.
Thank you.
Bye, sir. Thank you.